Okay, this is the 1-2 modeling with expressions notes. I'm going to I have the assignment, the HRW assignment open as well as the notes. So I'm going to show you how to make sure to type things in correctly for a few of the questions. So modeling expressions. An expression is where you're taking a set of information and you're expressing it in a mathematical phrase that contains operations, numbers, and or variables. The terms of the expression are the parts that are being added together. So every piece that's being added together, and added can be a minus sign because remember, minus really means plus negative. And then a coefficient is the numerical value that is associated with only the variables. Okay. So a numeric expression contains only the numbers, only a numbers such as 2 plus 3 and 5 minus 3. But an algebraic expression contains at least one variable, so a plus 4 or b squared minus 4. Those are algebraic expressions. So the first kind of problem that you're going to see, like the one you see on my screen, is identify the terms and the coefficients. So the terms are the pieces of that expression that are again being added together. So for my example, 8p plus 2q plus 7r, this is a term, that is a term, and that is a term. It's like three different people in your room, and you're adding up all of the change they individually have in their pocket. So P is Paul, he had 8 cents in his pocket. Q is Quirky, and he has 2. And R is Randall, and he has 7. So we're adding all those up. They're individual terms, they have individuals. Now, of these three, Paul has an 8 as a coefficient because he's the one with the 8 cents, so to speak. Q has 2 and R has 7. So those are your coefficients. So looking at your problem here, you'll notice that there are three terms. One of them does not have a variable on it. That one is not going to be one of your coefficients. That's called a constant. So our terms here is still going to include that, but it is not going to be with the coefficients. So you'll put in -7. If you do not see when you click on something, if you don't see a box here, you need to click over here into this to create a box. And then you type inside the box 3p. Oops, it's a little slow for me. And then -9z. So the signs go with the terms. So -7, +3p, -9z. And for the coefficients, the same thing applies. So for the coefficient for 3p, it's a +3. For the coefficient of -9z, it's -9. Okay? And just so you can see, when you check your answer, it should come up correct. I wanted to point out a few things while I have this up here. As soon as it goes away, you do have the option of looking at an example that will talk you through the question or will show you what to do for the question. And when you do push example, it will ask you to try another. So this does not count against you in terms of getting it wrong. It's just giving you something to kind of get an idea. Well, what should I do? Like you were seeing it in your textbook. If you do step by step, that one will talk you through step by step, tell you exactly what to do, and then it will give you a chance to try another. But if you use the step by step, it does take half points off for using the try another. Okay, let me go back to my notes. So here's another example. I'm not going to run through the one on the computer. It is identify the coefficients and the terms. So our terms are 18, -2x, and -4. I wrote them in different order. I wrote them in the standard form that you would normally write it. Normally this would be written x, y, constant. So it can be written in any order, and it doesn't really matter how you list out your terms. Just remember, coefficients only associate with variables, and they keep the signs that they had in there. So here's a graphic organizer to help y'all. So you would put your expression in, and your expression would be, say, 9x minus 90y minus 40, which is the problem that's on there. And then you would decide, well, what are the terms? Well, the terms you would say are 9x, comma, negative 90y, comma, negative 40. That's easy. What are the coefficients? Now we look at the numbers in front of the variables. So that's 9 and negative 90. Then we look for the variables. Well, what variables do we have? We have an x and we have a y. And what constants we have? These are the numbers that don't have a a variable, which is going to be negative 40. So that gives you a way to kind of organize your thoughts. The terms also give things in context, and the coefficients will tell you how much per unit variable that would be worth. It's kind of like if you were buying groceries and you were getting apples. Apples would be 0.75 cents per pound. Pound is going to be your variable, P, and 0.75 would be your coefficient, which is how much it costs per item. Okay. So we're also going to be talking about integers. I'm going to introduce it here and then go into a little bit more detail later. We denote integer inequalities, between expressions using the less than, greater than, less than or equal to sign, or greater than and equal to sign. Okay. Some keywords to remember for less than is either less than and then greater than. But for less than or equal to, it could be less than or equal to, or you could see at most. For greater than or equal to, it could say at least. So those are kind of weird because these are backwards. You would think that at most would be greater than, but it's actually saying the biggest number you can have that variable x can be is the, say 10. So x has to be less than 10 is what at most means. And x being greater than the smallest number you can put it being, meaning everything bigger than that number. So that's going to be at least. So if an expression are the same or equivalent equations, then we use the equal sign. Other ways that you might see the word translate from the word equals is were, is, equivalent to, the same as, are, will be, was, is equal to, or the same. Also, so some operational words, keywords to remember. Keywords, when we are doing our cubes, are going to be boxed. When we're doing word problems, we're going to box in keywords. So that's the B part of cubes. So for addition, you have the plus sign. An example is A plus B. These are keywords that you might see: the sum of, added to, plus, more than, total, and, altogether, or increased by. And what I was saying with the cubes is we'll circle our numbers and box in these keywords. Okay, for subtraction, we have less than, minus, subtracted from, the difference of, taking away, reduced by, or less. For multiplication, we have times, multiplied by, the product of, and the percent of, or just simply the word of. Sometimes that's all that they give us, a number of something else, okay? Or out of. Actually, out of is usually division. Okay, divided by, division of, and quotient of, divided into, and ratio of are all keywords for that. And a couple of things to remember. In multiplication, we no longer use x. You do not use x for multiplication in Algebra 1 or any math up to the after this. You are going to use a times or a dot, or you might have numbers bumped up against parentheses. Those all mean multiplication, but you cannot use x. If you're going to put something between them, make sure you either use a star, or I prefer, and I would suggest you use a dot. It's quite quicker, much quicker. Or you put things in parentheses. Also, put all negatives in parentheses. It will make your life easier. For division, we can use the division sign or a slash. So A divided by B is the same thing as A divided by B, where you're using it as in a fraction form, or A/B, which is what your computers will let you type it as. Okay, so here's your turn problems. You want to identify and the terms and the coefficients of the expression. So take a couple seconds to pick your answer. For first question, your answer should have been, oops, gotta get the right one. Your terms would be a 9a, 4b, and negative 18. Your coefficients are 9 and 4. And this was not asked, but I wanted to point out that the negative 18 is the constant. So it's not one of the coefficients, but it does have its own special name. All right, problem number 2, pick your answer. Okay, you should have gotten terms of 8x, negative 20y, and negative 10. The coefficients are 8 and negative 20. And then it didn't ask you this, but the constant is negative 10. Okay, so we're going to do a word problem. I'm going to refer back to cubes. That's our method to problem solving strategy. You want to identify the factors of the terms of the expression and what they represent. So Erin is buying produce at the store. She buys a cucumber at 99 cents each and A apples at 79 cents each. What is an expression? Okay, so using cubes, we would first circle all of our numbers. Well, our numbers is 99 cents, 79 cents, and then we'll circle the equation. Okay, and then it asks, and U says to underline. So we're going to underline, what does the expression represent? Sorry. We want to box in any keywords. So I see a keyword that says and remember from our previous page, and means plus. So this is C plus A, C at 99 cents each. Each is also a keyword. It gives us a clue that something's being multiplied. Okay? So that's where they get the idea of 99C, 99 cents times C number of cucumbers. There's our variables. Plus 79 cents times A, and meant plus. So what is this actually doing for us? It's telling us, and we're doing the next step, which is to eliminate, where's my blue? E actually means two things. It means to eliminate and to evaluate. So we're going to eliminate information in the equation and the sentences that isn't important. Well, we don't really need to know that she went to the store. Okay, that's information that we really don't need to solve it. Evaluate means that we need to know the equation. Well, they gave us the equation. So that's the thing that we're going to do. We're going to take and evaluate. Now we're going to solve it. Well, what did it ask us? What does it represent? Well, this plus, another key word for plus, it's total. So this is telling us the expression represents the total cost, because these were dollar amounts, of C cucumbers. We don't know how many she bought, but whatever amount she bought plus whatever amount apples she bought, when you put those into this expression, you find out what her total was when she got to the register. Okay, so that's the cubes process. And follow the cubes process. Write it down on the side to remind you what to do. So circle numbers, underline the question, box in keywords, eliminate and evaluate, and solve. So your turn problem is the price of a sandwich is $1.50 more than the price of a smoothie, which is D dollars. What does the expression D plus $1.50 represent? Okay, so your answer that you should have chosen is the expression represents the price of the sandwich. So it's telling you, the word is was our key word that tells us we're going to be doing some kind of a total there. And then it said more than $1.50 more than, which tells us that we're doing a plus. So that kind of gave us an idea of why they came up with that information, and is tells us that we were looking for the total price. Okay, so we're going to write an expression to the model given the context, and give your answer in simplest form. So this time they didn't tell us what our answer would be. They want us to read through it and then create our own expression. So again, we're going to use cubes. The number of gallons of water in a tank that already has 300 gallons in it after being filled at 35 gallons per minute for m minutes. So we're going to circle our numbers and variables. So 300 is a number, 35 and m are going to be circled. And then we're going to underline our question. Well, our question was actually the directions. So that's coming from there. Okay. And make sure you underline that you want it in simplest form. I would even highlight that part, or make a big note of it, because that's where you might have errors, is because you didn't simplify. Okay, we're going to box in our keywords. So we had the number of gallons of water that already had. So this is something that already had, even though it's not really a really big clue, it tells us that we're going to be starting from there and going up. So that's a clue for adding. After being filled, 35 per. Per is a clue for multiplication. So we have 300 plus 35 times m, and that's how we get it. So we're basically doing that, pulling out the pieces and ignoring everything else. Okay, so next one is your turn. The original price of P of a item less a discount of 15%. And remember to put this in simplest form. So your answer would have started out with the original price P of an less a discount of 15%. So to get a discount on something, you take that percentage and multiply times the price. So that's where that came from. But this is not simplest form. We have to first do that subtraction. And remember, P is also 1.0 or 1P. So 1 minus 0.15 is where 0.85 is. So our answer ended up being the simplified form of 0.85P.